All right, hi everybody. I am back in the laboratory again today. We are going to be doing the liver lab. I've got it mostly set up, so we should be able to do the liver lab really quickly. Make sure that you have your liver lab open on a separate tab, so as I'm going through this, you can be entering in your data as we go. So what we're taking a look at with the liver lab are enzymes. And when we say liver, we're talking about cow liver. We're actually using liver that I got from the grocery store. The only reason we use liver instead of hamburger, instead of some other meat, is just because it's an inexpensive meat that we can get at the grocery store easily. But it could have been anything, just to show the impact of different variables on enzymes. So remember that an enzyme is a protein, and it's a protein that speeds up reactions. So today we're going to do two control groups. We're going to take a look at an example that does not have an enzyme in it and see what happens to that reaction. We're going to take a look at an example where there's a catalyst, but it's not an enzyme. And the reason it's not an enzyme is that it's not made by the body. It's just an element that we find in the earth that acts like a catalyst. So we'll look at that. And then we're going to look at the liver, and we're going to change variables about the liver, the enzyme that's in liver. The enzyme is called catalase. And catalase's job is to break up hydrogen peroxide. So hydrogen peroxide's equation is H2O2, kind of like water, but with an extra 2. And when catalase touches that hydrogen peroxide, it breaks it into water and oxygen. And we see the oxygen because it starts to bubble, and that's a way that we know that the catalase is working. So today we're going to be looking at 3 things each time we do the experiment. We're going to look at a temperature change. When these reactions occur, there's usually heat that's given off, so we'll see how much heat is being given off. We will record how much it's bubbling. That's a very, what's the right word for that? I'm forgetting the word, but kind of your opinion, how much it's bubbling. So if it's not bubbling at all, we're going to give it a 0. If it bubbles over the top of the test tube, then we're going to give it a 10. So that just kind of gives you a sense of where we are. Halfway up the test tube, we're going to give it a 5. Looks like I'm getting kind of a bad connection. I hope this is recording well. If it keeps doing that, I'm going to start over. Okay, so anyway, we're going to look at those 3 things, and then we're going to try to answer some questions about what was actually happening to the enzyme that's in liver. So we're going to just look at it, the liver in normal room temperature. We're going to look at the liver when it's really, really cold. So what impact does cold have on enzymes? We're going to boil the liver. I already did it. So we can see what impact super high temperatures have on enzymes. Like if you had a really high fever, what would that do to the enzymes in your body? The cold one is supposed to represent, like if you were outside on a winter day, what happens to your enzymes if your body starts to actually get really cold. And then we're going to take a look at the impact of pH. So what does an acid do to enzymes and how well they function? What does a base do to enzymes and how well they function? And then we're going to compare that to distilled water and see how those affect it. So let me go ahead and get us started. I've already got everything set up, so it should go fairly quickly. You just need to make sure that you have your data table open and ready to record results. So I've got all kinds of stuff right here, so I may as well walk you through. So this is the hydrogen peroxide. I already filled a whole bunch of graduated cylinders with 3 milliliters of hydrogen peroxide so that I could do this as fast as possible. This chemical here is called manganese dioxide, and that's in our test tube number 2. This is the same stuff that we put in gunpowder. I just wanted you to see, and it's going to be our catalyst today. That means that it will speed the reaction, but it won't actually be involved in the reaction itself. I have splints for doing, I forgot I didn't even say that. We're going to do a splint test today. What that means is that we're going to start the splint on fire. I have a lighter here. Hopefully it has enough lighter fluid in it to work. We're going to blow out the splint, and then we're going to put it into the test tube. And while the test tube is bubbling, if those bubbles are in fact oxygen, then the splint will relight. If those bubbles are carbon dioxide, like the bubbles that you would get in pop, for example, then the splint will be put out. The flame will get put out. So we're going to do a splint test. And for the splint test, you just need to say yes or no. Either it relit or it did not. And so a yes if it relit and a no if it did not relight. Okay, let's go ahead and start. We're going to do the very first one, and the first one is a control group. I'm going to lean my camera forward a little bit more. The first one's a control group, and I'm not expecting really exciting results with this one. So this is just sand in the bottom. Sand is neither a catalyst nor does it have an enzyme in it. I'm going to pour into it the hydrogen peroxide, and I'm going to observe it to see if there's any bubbling. I'm also going to take a temperature. I should have taken a before temperature. I forgot to. Oh no, on my crap, my thermometer was contaminated. Whoever had this last time didn't wash it. Give me just a second. I'm gonna pause to wash off my thermometer. That should not have happened. All right, I'm back. I washed off my thermometer, and I'm going to try something that I should have done in the first place. I put the thermometer into a test tube that has hydrogen peroxide in it, just so that we could get a starting temperature. Our starting temperature today will be the same all day long because it's just coming out of this bottle. So whatever the starting temperature I record right now, that'll be our starting temperature for everything that we do. And then I'll put the thermometer into the. Look at how much that bubbled. That wasn't supposed to bubble at all, you guys. So we'll take a look at the temperature change for all of them after that. So the temperature, it looks like the starting temperature today is 26 degrees. It looks like it's 26 degrees. And that is in Celsius, you guys. That's in Celsius. So 26 degrees Celsius. That'll be our starting temp. And while this looks super bubbly and frothy, sucks, we're going to assume that the temperature change, this all sucks, that started out wrong. We're going to assume that the temperature change was 0. So for the after temperature, we're going to go ahead and say that after temperature was, that the after temperature was 26 degrees also. Now I'm going to do the splint test. Let's see if I can get this lit. So this is how we do the splint test. All right, so I'm going to blow this out, and I'll show you what is not supposed to happen, but it will happen when I put it in there. I don't know if you could see that, but the splint relit when it touched these bubbles. That's not supposed to happen, so don't write that down. It happened because we had a mistake right at the beginning. So let me be really, really clear with what you need to write down for your first one, the first sand experiment. The temperature, the starting temperature was 26. The ending temperature was 26. Bubbles should be 0, not all frothy like it was. And the splint test should be a no. Sorry that turned out funny. So we'll get rid of that particular test tube because that did not work very well. All right, let's try the next one. The next one is that manganese dioxide I was telling you about. It is a catalyst. It's a chemical that we find in the earth, and it's something that we make gunpowder out of. I'm going to go ahead. The starting temperature, again, remember, will be 26 degrees. I'm going to go ahead and pour the hydrogen peroxide in. Oh, and we're seeing that it is bubbling. You should be able to see that. I'll try to bring it as close as possible so you can see it bubbling. I'm going to go ahead and get a quick temperature change to see how we're doing. Get that all in there. And then I'm going to light my splint again so that we can also check for the presence of oxygen. Give me a moment to get that splint lit. Did not work. There we go. Okay, so it looks like the temperature is recording at 37 degrees. So write down 37 degrees. And now I'm going to blow this out and we're going to see, oh, sure enough, we got it to relight. So that's a positive for the splint test because it relit. So for this one, you should have written the starting temperature was 26. The ending temperature was 37. You could rate the bubbles on your own. So if it got to here, then you would say it's a 5. If it got to the top, you'd say it was a 10. But you rate the bubbling yourself. And then the splint test was a yes. So hopefully that's everything. Let's move on to the next one. All right, the next one is a whole chunk of liver. So I've cut the liver with a razor blade. And now I'm just going to go ahead and add the hydrogen peroxide to it. Again, the starting temperature every time is 26 degrees. I'm going to go ahead and pour this in and see what happens. Oh my goodness, that's some serious bubbles. And we're definitely going to give that one a 10. When it bubbles over the top, it gets a rating of 10. Now I'm going to try to move quickly because I need to do a couple things. I need to do my splint test, before all of the bubbles go away. Try that again. And now I blow out the splint like that, and I put it, and it's hard to show it, but it did relight again because that's all oxygen there. So that would be a positive splint test for the whole liver. And then let's go ahead and get a temperature change on this. Look at that disgusting mess. I'll give it a couple seconds for the temperature to change, to rise up in the thermometer, and then I will tell you what the temperature reads. We'll give it just a moment more. And the temperature reads, not very high. It reads 30 degrees. So just all that foaming, and we only made it go up about 4 degrees. So 30 degrees for that temperature change. All right, we'll be done with this one. That was the whole liver. Next, we're going to take a look at the crushed liver. I'm going to clean off my messy thermometer, like I should have done the first time. All right, and now I crushed this liver in a mortar and pestle. I did add a little bit of water to help it crush a little bit better. And now I'm going to add, the hydrogen peroxide to it. Oh, Nelly. That would be another 10, it looks like, right over the top of it. So we'll go ahead and try another splint test. It's hard to do the splint test when they bubble all the way up to the top that way. So we'll take a look. Come on. Starting on fire. I'm going to blow out some of the bubbles just a little bit to see if I can get it to... Nope, I can't really. It just gets, the bubbles get it wet. So I blew out my splint, and now I'm going to put it in there. And it, yeah, the bubbles just get it wet, but you have to trust me that it is lighting. It's going poof, a little flash is coming up, but it doesn't work very well when the bubbles get it all wet. All right, so let's make sure we're clear on that. So for the crushed liver, we have a 10 on that one. We would say the temperature, I forgot to do the temperature change. Let's get that. For this one, we would say a yes for the splint test. It was definitely a positive test for the splint test. And then we're waiting on the temperature right now. We'll give that just a moment. While I'm waiting on the temperature, maybe I'll tell you about the next one. The next one that I'm going to try to do, and it might not work very well, is the frozen liver. I don't have a freezer. I don't have access to a freezer. So I have the frozen liver sitting in some ice right now, but it looks like it didn't really freeze. It looks like it's mostly room temperature. So I don't know that this one's going to work the way I want it to. So maybe I'll actually just skip that one. So maybe we'll skip the frozen liver. I'm not really gonna skip it. Like, I want you to write it down in your data table, but we just won't do it because it doesn't look frozen. So for the frozen liver, actually before we do it, let's take the temperature. So we're on the crushed liver right now. Let's see what the temperature was. And it looks like the temperature is about 29 degrees. The temperature is about 29 degrees for this one. So it just went up about 3 degrees, not really warm. Not like that first catalyst that went so high. All right, for the frozen liver, let's just talk through the frozen liver instead of me actually trying to do the frozen liver since it's not really frozen. If the liver were really frozen and we poured the hydrogen peroxide into it, scooch up so you can see my face. If we poured hydrogen peroxide into frozen liver, what should happen is that it should bubble really slowly. It'll be bubbling and bubbling. But this reaction gives off heat. So the more it bubbles, the more the liver warms up, and then all of a sudden it starts bubbling like the normal, regular room temperature liver did. So what we're noticing is just the speed of the reaction, that the frozen liver bubbles slowly, but it still bubbles. It doesn't have any problem. It still bubbles. It just does it really slowly. And that's what's happening with hypothermia. When we get really, really cold, there's nothing wrong with the enzymes in our body, but they slow down. And so all of our metabolic processes, including our ability to think, slows down when we get really, really cold. All right, the next one that we're gonna do, I'm gonna take this test tube away. This was for the frozen liver, so we're not gonna do that one. Oh, and let's give some data for that one though. So let's say for that one, let's say the initial temperature is 26, the final temperature is 27 because it warms up over time. We'll say the bubbles, we'll give it a 10 also. The bubbles are really high for it. And then the splint test, we would say a yes for that one. So that one's definitely a positive also. Okay, now let's go ahead and try the boiled liver. Now I boiled this liver already on our hot plate. So there's the liver, it's been boiled. And I'm gonna go ahead, let's scooch it over here so we can see it pretty well. I'm gonna go ahead and add hydrogen peroxide to it. And then we'll take the temperature and do all that business. So this would be like if you had a super, super high fever, over 108-degree fever. This is what happens. Whoa, Nelly. This is what would happen if you had over 108-degree fever. Your enzymes denature, which basically means your enzymes melt. They change shape. And if you can tell, there's no bubbling going on here at all. It is completely ruined. So the enzyme is not functioning. Now we might see a little bit of a temperature increase only because the boiled liver is warm. So the temperature might go up a teeny bit, but not too much. And I'll go ahead and do a splint test, but that seems a little silly since we didn't have a single bubble. It seems pretty obvious that the splint will not light, but I'll go ahead and do that in front of you so you can see it. There we go. So it looks like the temperature did not actually change, so it's still at 26 degrees. So we'll take that out. I'm gonna go ahead and blow out the splint, and we'll put it in there and see if anything happens. No relighting. So no oxygen was produced. That's what this is a test for, is for oxygen, and no oxygen was produced there. So it did not relight the splint. So for this one, you would say 26 degrees, 0 for bubbling, and then for the splint test, a negative. Okay, the next one we're going to change. We're going to start messing with the pH of the liver. So remember, pH is whether something is an acid or a base. Your blood is supposed to be at a pH of 7, which is like water. And that's where your enzyme called catalase lives. You guys have the enzyme also. It's not just cows that have this enzyme. So it's supposed to work best at an enzyme at a pH of 7. So we'll see what impact adding acids and bases have. So I have the acids and bases ready back here. I'm just going to scooch back so you can see them. This graduated cylinder has in it, it has 3 milliliters of hydrogen peroxide so that it'll bubble. And then it also has 2 milliliters of an acid. The acid is hydrochloric acid. So I'm going to take this is just regular liver. I didn't boil it. I didn't do anything to it. It's just liver. And I'm going to go ahead and add the acid and the hydrogen peroxide to it. And we're going to see what happens. Ooh, KJ, that's interesting. Pretty much nothing's happening. Lower it a little bit, bring it close to make sure you can see. I don't see anything going on with the acid at all. Maybe a tiny bit. Maybe a tiny bit. Could we give it a 1 for bubbling? So really, really small amount of bubbling. There we go, a little bit of bubbling there. And I'll give it just a moment for the temperature, and then we'll do a splint test again. Get a new splint. That splint was wet. So I'm looking, we're going to give it a 1 for bubbles, and a temperature, boy, it doesn't even look like the temperature's going up, maybe a 20, yeah, I'm going to still say a 26, I think. I don't think the temperature increased at all. Okay, here's my splint test. Let's see if we're going to give this one a positive splint test. We blew it out, we're going to put it in, and I would say, nope, that's a negative. So that's a negative splint test. The splint did not relight. So for the acid, we'd say the temperature basically stayed the same. We'd give the bubbles a 1, and we'd say a no for the splint test. All right, now let's try we got an extra tester here. Now let's try the enzyme in a base. So I'm going to go back over and grab the base. This is sodium hydroxide. So we've got hydrogen peroxide and sodium hydroxide in here. So we'll go ahead and pour that in. Ooh, that's unexpected. That's a lot of bubbling, ladies and gentlemen. Not as high as the ones we saw initially. So I would give this one a 9 for bubbling. So it's doing pretty well, but not as well as the ones that went over the top. So this is sodium hydroxide. I'm going to go ahead and get a temperature check on this one. Give me just a second on this one. And I should get the splint test. I'm going to guess we'll get a positive splint test for this one. Getting the splint ready should show you getting it ready. Okay, and we'll blow it out. Let's take a look at the temperature. Temperature says 29, and let's see if we get a positive splint. Actually, we did not get a positive splint for that one. That's surprising. Maybe I'll try that one more time just to see. So the temperature was 29. I'm going to do the splint test one more time just to see if we get anything for that. It'd be surprising to have that many bubbles and have a negative splint test, but we'll try. So there it is again. We'll blow it out. We'll try it one more time. Yeah, I don't see anything. Let me try spinning it just a little bit more. Nope. I'm going to say that's a negative splint test. That's a little bit of a surprise result. Oh my goodness, trouble talking. So a negative splint test for that one. So the temperature, I think we said, went up to 29. We gave it a 9 for bubbles. And the splint test was actually a no, which I think is quite surprising. All right, now let's do the very last one. This last one is the pH that blood is supposed to be. So this is going to be distilled water and hydrogen peroxide. So it's not an acid or a base, it's neutral. And we're going to add this to it and see if this does better or worse than the acid or the base. We'll pour that in. And it looks like it did better than even the base. The base did pretty well, but this is definitely a 10. In fact, this is better than just about any of them we've had so far. So this is definitely a 10. Let's get that thermometer in there so we can get a sense of the temperature change, and then I'll get a splint ready so we can do a splint test. Wouldn't that be funny if we didn't get a positive splint test? Give it just a moment. I'll light my splint here, and then we'll give it a moment to see if what the temperature looks like. Pull that out, and the temperature is a 29. There we go. We got some bubbles out of the way. Blow that out, and it lit back on fire again. So that's definitely a positive test with that one. That's what we would expect. See if I can get it to do it again. I can get it to blow out now. There we go. So let's try it. See if we can get it again. Yep, I've made a little flash. I don't know if you can see that on the screen there, but so we'd say it's a positive splint test, and the temperature is 29 degrees. All right, that should be it for the results. So now what you need to do is answer the questions after the lab. Make sure that your data table is all filled out, that you've written everything down, and then we'll answer the questions at the end. I think that's it. Let me know if you have any questions. Thanks. Bye.